Maurice asked how to do problem 10 from the homework. Now this is one of the most challenging problems that we'll do in the entire class. It involves almost everything we've learned. You have to use momentum, you have to use energy, and you have to use 2D kinematics. So here's the setup. You've got quiet. Hey. You got a block at the top of this ramp that's sitting on a table, slides down, collides with a second block. The second block gets knocked off the table, hits the ground. The first block rebounds back up in this elastic collision, returns to some other height, and then slides back down and flies off the table too. So we want to answer 4 questions. First one is find the velocities of each of the 2 blocks after the collision. Second question, ask how high block 1 rebounds after that. We want to figure out how far M2 travels as it lands. And we'll do the same thing for M1. After it rebounds, goes up the ramp, goes back down the ramp, how far does it travel horizontally? So we got to use all the tools at our disposal. And I'm going to sketch this out kind of quickly. I don't want to go through all the algebra because the video would be way too long. So I'll just show you the process. So first thing to do is we need to figure out the speed of block 1 right before it hits block 2 in that collision. And we can do that using conservation of energy. This is a frictionless ramp, so we have the initial height, final height. We can figure out the speed of block 1 by using conservation of energy. So this is pretty standard. There's its initial potential energy. Its final kinetic energy is 0. Sorry, its initial kinetic energy is 0. Its final potential energy, we'll call that 0. Let's say that 0 height is at the table. And there's the final kinetic energy. We're going to solve for this thing. And there's the speed of block 1. Now these 2 collide in an elastic collision, and elastic collisions are pretty complicated. I don't want to spend much time on them. In fact, this is the only problem that has them. I won't put this problem on a quiz or an exam. When you have an elastic collision, you got to use 2 equations. First equation is conservation of momentum. So this one is kind of what you expect. And the second equation is derived from saying that kinetic energy initial equals kinetic energy final. And there's a whole bunch of algebra that goes into writing this thing. We're not going to derive it. So it's a system of 2 equations, which you need because there's 2 unknowns, the final speeds of each object. So first equation, conservation of momentum. There's the momentum of block 1. There's the momentum of block 2. Block 2 is stationary to begin with, so we can cross that out. And there they are after the collision. Both of these are unknowns, so we need a second equation. Here's our second equation that comes from conservation of energy. The initial velocity of block 2 is 0, so we cross that out. Then you do some algebra magic. It's up to you to do that on your own. And you can solve that system for V1 final and V2 final. And keep in mind that mass 2 will have a positive velocity, it'll be going to the right. Mass 1 will have a negative velocity. It rebounds to the left. Okay, next question. How high does mass 1 rebound? Well, now we can use conservation of energy again. There's the initial potential energy. Again, we're saying 0 at the table height. There's its initial kinetic energy using the value that we figured out in part A. Final potential energy, this includes the thing we're solving for, that height, the rebound height, and the final kinetic energy, when it reaches the maximum height, that'll be 0. Okay, so we can easily solve for that rebound height there. Okay, now we're going back to 2D kinematics. How far do these blocks travel when they fall off the table? To figure that out, we need to know the time that they're in the air, and then we can multiply the time by their horizontal velocity to find the distance traveled. So we'll use our favorite kinematic equation, number 3. I'm doing block 2 first. So the final height is 0. I'm now kind of revising my, actually it doesn't matter, maybe to be consistent, I'll call final height negative h2 and initial height 0. Oops. There's h2, because we had been saying that 0 was the table height. So when it lands, it's a height h2 below the table. It started out at table height. Block 2 started out with, let's see. Oh yeah, block 2 started out with 0 vertical velocity. So that's 0. This is the y direction. And there's our acceleration, because the acceleration is coming from gravitational free fall. That means that M2 is accelerating at negative g. Okay, so there's the time to hit the ground, and that means the distance traveled is that horizontal velocity times the time. Similarly for block 1, block 1 goes up the ramp and then comes back down. By the time it returns to here, it's going to the right with the same speed we found in part A. Immediately after the collision, it had that speed, but the velocity vector was going to the left. But then after it goes up the hill and then returns, it has that same speed with velocity pointing to the right. That's because energy is conserved. So the distance traveled by block 1 is also its horizontal velocity. And I made it clear here that you use the positive value times that same time, because both objects take the same amount of time to hit the ground because they start at the same height. And the only thing that influences that time is how high they are off the ground. Okay, so that's a lot of stuff in one problem. This is the kitchen sink of physics problems in Physics 6.